Leptos is a full-stack web framework for Rust that runs in Rust on the server and compiles to WASM to run on the client. One feature that I find particularly interesting is Leptos server functions. This is a feature that you'll really only find in the examples at the moment, or if you dig into the crates and other code. Leptos server functions are a way to ensure that some bit of code runs on your server only rather than on the client in the browser. You likely want this behavior for one of two use cases. Firstly, running heavy code that otherwise could run in the browser. For example, you may want to syntax highlight user-submitted code, but not include every language in existence on the client. Or you may have a really big AI model that you can't reasonably ship to the client. The second use case is running code that has to be run on the server. Examples of this include database queries that need access to secret credentials to talk to your database. Server functions then effectively fall down to being just this macro. Here we have the server function macro with a struct that we've named add to do, as well as the URL of the handler that's going to be handling any of our server functions. The piece of this that I really like is that we get to write an async function that only deals with the arguments we actually need it to, and the code that runs on the server and on the client is generated from this macro. So in this case, we have an add to do function that takes a title. This is the to-do list application inside of the Leptos examples. This function returns either unit or a server function error, which is a common error type to return from these functions. In this case, it's a SQLite database, so picking up the connection doesn't actually take that long. So there's a sleep here to make it take a little longer. And then we use SQLX to actually connect to the database and insert the to-do item. Now we're using a SQLite database here, but you could imagine that this code is connected to, say, a PlanetScale database or AWS RDS or any number of other SQL databases that actually need secret credentials to talk to. So this code isn't code that we want related to the client really at all, which is kind of the key insight to server functions. We write what we want to happen on the server alongside the arguments that we want to use to enable that functionality. And if we expand that macro, we'll see the add to do struct that we've defined with the arguments in it that we defined, and a version of call function that runs on the server and a version of call function that runs on the client. If we look at the implementation of these two functions that are generated, one of them is effectively exactly the same code that we just wrote. This is what runs on the server. This is why we can write code that actually talks to the database or uses our environment variables on the server. The client-side call basically sets up the call for us to the API that we just created and handles the response. So you can see these are guarded by config flags. So if we enable the SSR feature, then this add to do function gets compiled into our application, and that will run on the server. In any other case, such as when hydrating on the client, the SSR feature won't be enabled, and what we'll get is a call to the appropriate URL with the appropriate arguments that we gave it. This is actually quite a nice way to write sort of one-off UI-based queries. We don't have to flip back and forth between some server handler's directory or file and the UI code that's using it, because we've written everything that we want to happen right here. And if we look for the usage of add to do, we can see it just being used in our client-side application. In this case, it's being used in the to-dos component. Now, for the purposes of this video, create server action and create server multi-action, we don't need to care about the differences. So suffice it to say that we are creating this action that we can call to get the server code to run and get a response. There are two components that integrate really tightly with this functionality. So if we create a server action, we name that add to do or whatever else, we can use a component called action form or multi-action form, which will automatically handle taking all of the arguments in the form that we write inside of it, using those as arguments to pass to the server action here, which then gets passed on its way to the API, which then calls the server function and returns the result. So to add a to-do to our database, all we needed to do was define the function that is responsible for inserting the new to-do into our database, and then build a form so that the user can supply us with the proper arguments, and we're basically done. Now, there are a few catches. For example, all of these server functions need to be registered. They need to be registered because on the server, each of the server integrations, so in this case, we're using Axum, which means we're using the Leptos Axum integration. All server-side integrations have and handle server functions like default generic handler. This handles all of the server functions that we write. Now, it doesn't mean we can't add other APIs here, such as this get, but it does mean that by default, this generic handler, which is responsible for dealing with all of the server functions, will handle all of our functions. And thus, we need to register all of those server functions on this server so that this handler can look them up in a hash map to deal with later. But after you've registered any of your server functions, you can use them with fairly little boilerplate, which is really nice. Now, this brings up a kind of a point that I am on the fence about. I really like the API that comes out of this async function with the arguments that we need that generates the server and the client calls. But because we write it this way, and due to the way that the code is generated, we have to use Leptos's Axum integration to interact with our server framework, in this case, Axum. So what this means is that if you take a look at this Axum example, which I'll make a little bit bigger, this Axum example handler, which is a completely different application than the one we were just looking at, has a user ID from session. And this is a value that is extracted from the request for us and given to us in this handler. We do that by implementing a specific trait in a specific way. The details of Axum aren't so important, so I'm not going to get too deep into this. But suffice it to say that there are types and traits and implementations that we can use to get the data that we want out of the request or the body or anything else inside of this function, that because we are writing our functions like this, we don't have access to. So if you want to get something like the parts of the request, the Leptos Axum crate has its own implementation for how to get those. And there's some commented out code here, but if I uncomment it for the sake of education, you can see that we have to build up our own header map with headers and then overwrite pieces of the response from the Leptos Axum integration. So we're not actually able to use Axum's native methods and types for dealing with pulling data out or putting data into requests and responses. We have to use Leptos Axum's integrations, which don't match up one-to-one. This leads us into needing to use more of Leptos's APIs and specifically context providers to get any of those pieces of data that we would have extracted through middleware in Axum using Axum APIs. For example, if you have a session middleware that sets up a cookie and deals with that before it gets to your handler, that means it's before it gets to the generic handle server functions, then you'll want to get that data into the handle server functions context that gets provided to your server functions ahead of time. And that's why we see these new APIs handle server functions with context. So there is a bit of a trade-off. You have to write sort of a wrapper handler and decide ahead of time whether there's anything that you need to pull out or not. And this will be true for basically all of your server functions unless you want to start setting up multiple handlers with multiple different contexts. So if you only wanted that session or that cookie to be handled on a couple of your server functions, you would have to handle server functions with context multiple times to handle different sets of those server functions, which makes it a little bit more complex. Now, overall, I do think this is a really interesting API choice. I really actually like how little code it takes to actually write a server function and then use that in an action form. I just think my personal preference would have been for a little bit more direct integration with the server framework rather than being completely abstracted into the Axum world and needing to use context to communicate between the Axum server or the Actix server and the actual handler. Specifically right here in the arguments for add to do or delete to do or something like that, I would love to be able to put the extractors that I would otherwise use in Axum. But beyond that, it's a little bit of a speed bump, but I really am happy with this feature. And I think it's a really interesting piece of API design for when you're building applications with Leptos. That's it for today. I just wanted to bring up server functions in case you weren't aware of them, and I hope you have a great rest of your day. I'll see you in the next video.